So earlier, when we introed this information, instead of using A, B, and P here, we used that polynomial notation where it was kind of like A sub n times x to the n plus A sub n minus 1 times x to the n minus 1. You remember that? Kind of? Okay. If you don't remember it, it's okay. It's just, it was notation that we use at the higher level mathematics. Starting, it's intro to algebra 2. We deal with it here, but it's just the notation they use. It's very general. But instead of making it complicated, we're just going to say the leading coefficient is A, the next coefficient is B, and the constant is P. Those are the three pieces we need to answer this question, right? And what we're going to do is we're going to look at finding the sum of the roots or zeros of a polynomial, and then we're going to look at finding the product of the roots or zeros of the polynomial. At the quadratic level, this concept should make sense to most of you. But once we get to higher order polynomials, degree 3, 4, 5, and 6, you probably start losing, like, why are we even doing this? And that's a valid question that you might have. And what I can tell you for right now is, like, you're going to use some of this when you get into calculus and you talk about the roots of polynomials when you start studying those calc ideas, right? But for now, all you need to know is how to find the sum and product of the roots of a polynomial of degree n, okay? Right, so the sum is pretty basic, right? So imagine you just solved a polynomial, and I said, what's the sum of the roots? You add all the roots together. You could identify the sum quickly with this little formula. What you do is you take the opposite of the coefficient second term, right? So if it's a degree n, it's the very next term, n minus 1. So if it's a degree 3, this is going to be associated with x squared, right? So you take the opposite of b and divide it by a. Whatever that value is, that's the sum of those roots. So this polynomial, if it was a degree 3 and you added all three roots together, all three of those roots would add to the opposite of b divided by a. You're responsible for that little formula, okay? Product. Product is similar, but product, it's contingent on whether the degree of the polynomial is even or odd, basically, right? And you're still using A, but now you're going to use P instead, okay? So the product of the roots is positive P, or P, divided by A if n is even. So if the degree of the polynomial is even, 2, 4, 6, 8, so on, you simply just take the constant and divide it by the leading coefficient, P over A, and that's the product. Meaning if you had three roots of a degree 3 and you added them together, that's what the product would be. No, I'm sorry, not added. If you multiplied them together, that would be the product, right? So P over N, if N is even, right? If N is odd, right, 1, 3, 5, 7, 9, so on, it's the same formula structure, but you have to take the opposite of P, right? So whatever P is, change its sign, divide it by A. That's going to be the product of an odd degree polynomial function. So far, so good? All right. You find the sum and product using your formula.